All right, so I'm David Pelaz, and I'm going to briefly discuss my Signals and Systems project. So for question 2, we were asked to use MATLAB to plot the magnitude frequency response of a LTI system, right? And they give us the equation. So going to the code, here for this problem, they gave us h omega, which is the transfer function. And that's just simply the ratio of the output signal, let's say y omega, over the input signal, x omega, right? And here, so we put it into MATLAB, and we put in the constraint for the reason that our domain is from negative pi to positive pi. So that's the code right there. And here we put the code in for the plot. So we labeled our x-axis with omega and our y-axis with the transfer function. And once you plot this, plotting in the transfer function, h omega, will give you two graphs, which will describe the frequency response. One will be the phase, and the other graph will be the graph of the magnitude. So continuing on, the next question had asked us to find the impulse response. Now, the impulse response of a system is simply once we send an impulse through a system, and at the output, we're going to have an impulse response. So here, you're able to find the impulse response if we were doing it on paper analytically by simply just taking the inverse Fourier transform of h omega, and that will give you the impulse response. So here, as you can see in the code, we have once again created another plot, and we've labeled our x and y axis, and we gave it the title, impulse response. Okay, so right after that, for problem 2, part C, the problem had asked for us to basically put the same system in cascade with another system with same values. And doing so, we did here on MATLAB. Okay, and basically cascading these two systems, we're able to achieve this on MATLAB by just inputting in the convolution formula, which, as we know, the convolution is just the mixture of two signals right here, as we see, H1 and H1. And then we coded the other plot here for the impulse response, now that we have labeled as H2, which belongs to the cascaded system. And at the end, we put in some code for the difference equation of the impulse response for the cascaded system. And as you see here in our command window, this is the difference equation. Now, what I'm going to do is I'm going to hit run so we can see the actual graphs. All right, editor, run. Okay, so this is the impulse response of the cascaded system, abbreviation H2N, and this is the absolute value of the FFT of the cascaded system. Basically, this is the forward Fourier transform, and this is used in a discrete system. Here, this is our chart of the first impulse response when we only had one system. And this is our frequency response. This was for problem 2, part A. Once we plugged in the transfer function, equation, we got a graph of the magnitude of the frequency and phase of the frequency. Right. So I'm David Pelaz. This was my project for Signals and Systems. Thank you.